Good day, students. Welcome to our lesson this week in General Mathematics. In this session, we're going to have solving rational inequalities. So take a look at these rational inequalities. So the rational expression can be greater than 0. It could also be less than 0. There are also inequality symbols such as greater than or equal to 0 and less than or equal to 0. For our first example, find and show on the number line the solution of the inequality x plus 3 all over x minus 2 greater than 0. So last time, we had solving rational equations. Solving rational inequality is different because here we are going to need to make use of a number line. So the first thing that we have to do is to solve for the critical points. We can solve the critical points using the numerator and the denominator. Based on our given, we have x plus 3 and x minus 2. So first, let us solve for the first critical point using x plus 3. Let us equate it to 0. X plus 3 equals 0. So x is equal to negative 3. Our first critical point is negative 3. And then solve for the second critical point using the denominator. Equate it to 0. So it will become x minus 2 equals 0. So x is equal to 2. And that's positive 2 in the number line. So in the number line, remember that the negative numbers are in the left of the positive numbers. Then make a line here and other two lines here. Then broken line starting from the critical points. So first, put the numerator and then the denominator. And then our given, x plus 3 all over x minus 2. So we are going to make use of this to solve for the solution of the given inequality. So for x plus 3, the result or the value will be 0 if x is negative 3. For x minus 2, the value will be 0 if x is 2. That's why we're going to write 0 there. Okay? And then, look at x plus 3. So if we're going to substitute a number on the right of negative 3, let's say negative 1. So negative 1 plus 3 is positive 2. So the answer will be positive. If we're going to assign another number to x, which is on the right of negative 3, let's say positive 1. Positive 1 plus 3 is 4. So that's positive also. And if we're going to substitute a number on the left of from the left of negative 3, let's say negative 4. Negative 4 plus 3, that's negative. Another number, let's say negative 5. Negative 5 plus 3, that's negative 2. So if we substitute any number on the left of negative 3, the result will be negative. But if we're going to substitute a number on the right of negative 3, the results will be positive. Okay? For example, 2. 2 plus 3 is 5, so that's positive. 3 plus 3, that's positive 6, so that's positive also. So take a look at this. Negative, 0, positive. So it is like the position of numbers in the number line. On the right of 0 are the positive numbers, and then on the left of 0 are the negative numbers. Now, let's have x minus 2. So if we're going to substitute a number on the left of positive 2, let's say 1, 1 minus 2, that's negative 1. Let's make use of 0, 0 minus 2, that's negative 2. Okay? So if we're going to substitute any number on the left of 2 to x minus 2, so the result will be negative. Let's say negative 4. For example, negative 4 minus 2, that's negative 6. If negative 3 minus 2, that's negative 5, so still negative. Okay? And then if we're going to substitute a number on the right of 2, let's say 3 minus 2, that's 1, that's positive. Let's say 4 minus 2, that's 2, or positive 2, so that's also positive. Okay? So just like the number line, so on the right of 0, the positive numbers, then on the left of 0, the negative numbers. Okay, and then we're going to divide the results, because we have here numerator divided by denominator. So let us divide the results. First, so look at the first column, negative, negative. So since from our given, we have x plus 3 divided by x minus 2. So we're going to divide this. Negative divided by negative. And negative divided by negative is positive. Very good. Next, in the broken line, look, 0 divided by negative. So 0 divided by negative is 0. Okay? Then the next column, positive divided by negative. So that is negative. Now, how about positive divided by 0? So that's undefined. Okay? And then positive divided by positive is positive. Okay, so after we have obtained this, return to our given inequality. Take a look. X plus 3 all over x minus 2 greater than 0. Now, meaning to say, the left side of the equation is greater than 0. Look at the inequality symbol. Greater than. So, the numbers which are greater than 0 are positive numbers. It means that the result of x plus 3 all over x minus 2 must be positive. Okay? So, positive solution. So here, based on our number line, we're going to consider the positive that we have obtained. Now, take a look again. Greater than 0. So we need to say 0 is not included. Only the positive. So since 0 is not included, so that's hollow. And then positive, so that's going to the left. So let's draw an arrow there. And then since negative here, we're not going to include this. How about the undefined? So undefined is neither positive nor negative, so we're not sure, so it's hollow again, so it's not included. And then positive going to the right. Okay, and then take a look of this circle and arrow. So it's along or across with negative 3, or the critical point negative 3. So meaning to say, the possible values of x could be from negative infinity to negative 3. And negative 3 is not included. Other possible values of x from 2 to positive infinity, but 2 is not included. Okay, so if we express the solutions in terms of intervals, and since we have these two intervals are the solutions of that inequality, so the elements of these sets we're going to get the union of this. So the union of negative or negative infinity to negative 3 union 2 to positive infinity. So this is the solution of the inequality x plus 3 all over x minus 2 greater than 0. Okay? So let's have our second example. Find and show on the number line the solution of the inequality x plus 3 all over x minus 2 plus 1 less than or equal to 0. Again, x plus 3 all over x minus 2 plus 1 is less than or equal to 0. So the first thing that we have to do is to combine x plus 3 all over x minus 2 and 1 so that it will be a single term or a single rational expression. Because based on before we solve for the solution of an inequality, so a single rational expression first must be compared to 0. So the LCD is x minus 2. That's why it will become like this. X plus 3 all over x minus 2 plus x minus all over x minus 2. So remember that x minus 2 all over x minus 2 is equal to 1. Okay? So that's it. We only choose x minus 2 because that's the denominator of the given rational expression here. So we can combine this because these are similar fractions. Remember that similar fractions have the same denominator. So this will become x plus 3 plus x minus 2 all over x minus 2 greater than or equal to 0. I'm sorry, less than or equal to 0. Then, simplifying it, x plus x is 2x, 3 minus 2 is 1. So that will be 2x plus 1 all over x minus 2 less than or equal to 0. So now we can solve for the solution of this inequality. Let us make use of a number line for the continuation, and then we're going to solve for the critical points. So first, use the numerator 2x plus 1 equated to 0. We'll have 2x plus 1 equals 0. Then transpose 1, 2x equals negative 1. Divide both sides by 2. So we're going to have x equals negative 1 half. So that's our first critical point or critical number. Then use the denominator x minus 2 equated to 0. So we're going to get x equals 2. And that's our second critical number or critical point. So please place the critical number properly on the number line. Then, so make another line here again. So 2 lines. And then a broken line from our critical points. Then the numerator 2x plus 1, the denominator x minus 2, and the rational expression 2x plus 1 all over x minus 2. Okay? So 2x plus 1 will be 0 if x is negative 1 half. X minus 2 will be 0 if x is 2. Okay? And then, so it's just easy. On the left of 0, negative numbers. On the right of 0 are positive numbers. If you want to check, you may check. Okay, so let's assign a number from the left of negative 1 half. Let's say negative 2. Negative 2 times 2, that's negative 4, plus 1, negative 3, so that's negative. Okay, let us assign a number on the right of 1 half. Let's say 0. 0 times 2 is 0 plus 1, that's positive. Okay, so that's correct. And then again, x minus 2 on the left of 0 are negative numbers, on the right of 0 are positive numbers. If you want to check, you may check. Let's say negative 3 minus 2, that's negative 5. So negative, let's say a number greater than 2, let's say Positive 3, 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. So, positive. Okay, correct. And then the division, we're going to find the quotient of what we have obtained. So, negative divided by negative is positive. And then 0 divided by negative, that's 0. Positive divided by negative, negative. Positive divided by 0, that's undefined. Then positive divided by positive is positive. Now let us take a look at our given. Look at the inequality symbol. We have less than or equal to 0. So less than or equal to 0, meaning to say, the value of 2x plus 1 all over x minus 2 should be 0 or negative numbers. Because the inequality symbol is less than or equal to. The negative numbers are less than 0. 0 is equal to 0. That's why 0 and negative numbers are both considered. So 0 or negative numbers. Okay? So since we have 0 here, we have obtained 0. 0 is included. So if not included, we're going to use hollow. So we're going to use a solid. So solid dot or circle because 0 is included. And then 0 or negative. So where's that negative? There. Okay. So we're not going to the left because those are positive. Okay. So between 0, between negative 1/2 and 2. Okay. Only. So undefined. So undefined will always be excluded because it's neither positive nor negative. Or it's either positive or negative. It cannot be determined. So that's not included. So we're not going to the right because those numbers are positive based on what we have obtained here. So this will be the only interval, negative. So as you can see, from negative 1/2 to 2. Now, since 0 is included, or negative 1/2, so negative 1/2 here is included. So from negative 1/2, we're going to use bracket instead of parentheses. And then since 2 is not included, okay, because it falls to undefined, so that's 2. So meaning to say the solution of this inequality is from negative 1/2 included up to positive 2. So this is our answer. Okay, and then for our example number 3, find and show on the number line the solution of the inequality 2 over 3 minus x greater than or equal to 3 over x plus 2. Okay, so greater than or equal to is our inequality symbol. So we have to compare it with 2. So transpose the term from the right side of the equation. So that will be 2 over 3 minus x minus 3 all over x plus 2 greater than or equal to 0. So the LCD is 3 minus x times x plus 2. Okay, so that will be the denominator. Then the numerator, so that's 2 times x plus 2 minus 3 times 3 minus x. So simplify it, it will become 5x minus 5 all over 3 minus x times x plus 2. So our inequality now here is 5x minus 5 all over 3 minus x times x plus 2 greater than or equal to 0. So we're going to make a super number line. Let us solve for the critical points or critical numbers. So 5x minus 5 equals 0. That's the numerator. 5x equals 5, so x equals 1. Or x is equal to 1. So that's our first critical number. Then solve for the second critical number. 3 minus x So equate it to 0. 3 minus x equals 0. Negative x equals negative 3. So divide both sides by negative 1. We're going to get x equals 3. So 3 is our second critical number. So that's on the right of 3 or 1. Okay. Then the last critical number, x plus 2, equated to 0. We'll have x plus 2 equals 0. So x equals negative 2. That's our third critical number. So it's on the left of 1. Okay, so that will be our number line to be used. For the continuation, so we have now our number line and critical numbers negative 2, 1, and 3. So we have three critical numbers here. We have 5x minus 5, 3 minus n, x plus 2. So we're going to have more. So make a line here. So 1, 2, 3, 3 lines. And then another line. So 4. And then broken line from our critical numbers. So we have x, our 5x minus 5, 3 minus x, x plus 2. And then we're going to get the product of 3 minus x and x plus 2. So there. Okay, and then the numerator divided by the denominator, the given rational expression, 5x over 5 all over 3 minus x times x plus 2. Okay, so 5x minus 5 will be 0 if x is 1. 3 minus x will be 0 if x is 3. And x plus 2 will be 0 if x is negative 2. Now, so like what I've said before, on the left of 0, the negative numbers. On the right of 0, the positive numbers. On the left of 0, positive numbers. On the right of 0, positive numbers. Because our x here is positive. 5x and then x. Now, take a look of the second one. 3 minus x, okay? So that's a different case because x here is negative. Now, let us substitute first any number. So we're looking at 3. Any number on the left of 3. Let's say 1. 3 minus 1, that's positive. Okay? How about negative 2? 3 minus negative 2, that will be 3 plus 2. 3 plus 2 is 5. That's positive. Let's say we're going to substitute negative 5. 3 minus negative 5, that will be 3 plus 5, and that's positive. Okay? So you mean to say, on this case, since our x is negative here in 3 minus x, so it will be the other way around. Now, let's try to substitute a number greater than 3. Let's say 4. 3 minus 4, that's negative 1. How about 5? 3 minus 5, that's negative 2. Okay, so that will be positive. That will be negative. Because 3 minus 5 is negative 2. So, in this case, negative numbers are on the right of 0 and positive numbers are on the left of 0. Okay, so it's different now because our x here is negative. So for you to be sure, substitute first, diba? And then check your answer, check the results. So now we're confident that this is correct. So we're going to get the product of 3 minus x and x plus 2. So we're going to multiply the 2 because the product of these two factors is our denominator. So positive times negative, so that's negative. Positive times 0, that's 0. Positive times positive is positive. Positive times positive is positive. Positive times positive is positive. 0 times positive is 0. Negative times positive, that's negative. Okay, so this will be the denominator. Now we're going to perform the division for 5x minus 5 all over 3 minus x times x plus 2. So look at the first row and then the fourth row. Negative divided by negative, so that's positive. Negative divided by 0, so that's undefined. Negative divided by positive, that's negative. 0 divided by positive, that's 0. Positive divided by positive, that's positive. Positive divided by 0, so that's undefined again. Positive divided by negative, it's negative. And now take a look of our inequality symbol here, greater than or equal to 0. So greater than, what are the numbers greater than 0? Very good, positive numbers. So 0 or positive, because 0 is equal to 0 and positive numbers are greater than 0. Okay, so we're going to look at 0 here. 0 is included, okay. The undefined are not included. So we're going to the left here because of the positive, okay. And then 0 is included because it is greater than or equal to 0. So positive, but the undefined is not included. Okay, so there. And then since the last result is negative, so it is not belong to the solution of this inequality. So we're going to have this, express this in terms of interval, negative or from negative infinity to negative 2, not included. And then from 1 to positive 3, 1 is included but 3 is not included. So get the union of this. So the solution of this inequality is from negative infinity to negative 2, union from positive 1 to 3, where 1 is included. So that's your final answer. Okay, so that's this topic is very challenging but very interesting. So for practice exercises, solve for the following inequalities. Okay, so for number 1, 3x minus 1 all over x plus 2 minus 1 less than 0. So you're going to combine these two terms first so that you're going to have a single rational expression less than 0. Then number 2, you can proceed to the number line right away, but take note of the denominator, 3 minus x, so our x is negative. And then here we have for number 3, 1 over x minus 2 plus x over x plus 1 greater than or equal to 0. So combine these two also. For number 4, 3x minus 2 all over x plus 1 less than or equal to 0. Okay. That's easy, as well as number 5, x minus 1 all over 2x plus 3 less than 0. And then for number 6, 2x minus 3 all over x plus 5 greater than x minus 1 all over x. So here you're going to transpose x minus 1 over x to the left side of the equation and then combine so that you're going to get or arrive at a single rational expression greater than 0. Okay. And then for item 7, x plus 5 over 1 minus x greater than or equal to 0. So take note of the denominator again, that's 1 minus x. So it's similar with items number 9 and 2. Look at our example number 3. So you're going to have a clue. And then for number 8, 2 minus x is the denominator. So again, take note of that. And over x plus 3 less than or equal to 0. And then for number 9, 4 minus 2x over 4 minus x less than 0. So class, always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next week for our next lesson.